Hi children, here in the previous video we discussed up to that associative property. No, now here in this video we are going to discuss about that identity property. Okay, what is that? Identity property. Okay, what is that? Identity property. So here the first one, additive identity. Additive identity. Okay, and here multiplicative identity. So here we will discuss about that additive identity and multiplicative identity. Under that these all types of numbers. So what is the definition for that identity first? Okay, let A be any number, A be any number, then A plus 0 is equals to 0 plus A is equals to A. Okay, that is the definition for that identity property, which means if you add 0 to any number, if you add 0 to any number, then you will get the number itself as a resultant. Okay, if you add 0 to any number, then you will get that the number itself as a resultant. So actually additive identity means to that number which number we have to add, again we will get the same number itself. When it is possible, it is only possible for that the only digit, that is 0. Why? Because 0 means nothing, right? 0 is insignificant digit. So if you add 0 to any number, then which one you will get it as a resultant? Which number you are taking, that one only you will get it as resultant, right? So that's why here 0 is called additive identity element. Additive identity element. So which is called additive identity element means 0 is called additive identity element. Okay, 0 is called additive identity element. This is very important. Okay, so come to that in natural numbers. Here A plus 0 condition. In natural numbers they are asking, okay, is it possible to find that 0 in that natural numbers? So simply 0 is there in that natural numbers. 0 is not there in that natural numbers, 0 is there in that whole numbers. So in that natural numbers does not exist. In that natural numbers not belongs to 0, or 0 does not belongs to natural number. Okay, 0 does not belongs to natural number. That's why here under that natural numbers it is not satisfying. Okay, come to that whole numbers it will be satisfied. How? Because see here, in whole numbers A plus 0, 2 is a whole number and 0 is a whole number. Okay, so which is equals to 0 plus 2. So what you will get? 2 plus 0 is equals to 2 and 0 plus 2 is equals to 2. At last you will get the same number itself, no? So 0 will be start from that whole numbers type, right? Type of numbers, whole numbers. In natural numbers 0 not there, that's why here does not exist. Okay, when it will be satisfied means from that whole numbers onwards. So in whole numbers additive identity satisfies. Okay, come to that integers. Minus 2 plus 0, which is equals to 0 plus of minus 2, which is equals to, again you will get the resultant as minus 2. Yes or no? Minus 2 plus 0 is minus 2. 0 plus of minus is equals to minus 2. So minus 2. And here which is equals to minus 2 only, no? Resultant. Okay. So here if you add 0 to that minus 2, then you will get the resultant as the number itself. So satisfying or not? Satisfying. So integer satisfying. Come to that rational numbers. 1 by 2 plus 0 is equals to 0 plus 1 by 2. If you add 0 to that fraction, or if you add that fraction to that 0, then also you will get the same fraction as a resultant. So here rational numbers also satisfying. So these all numbers are satisfying means automatically real numbers also will be satisfied. Okay, only in that natural numbers only not satisfied. Why? Because in a natural number 0 will not be there. Okay, that's why. Okay, next one, multiplicative identity. Multiplicative identity means if you multiply any number with 1, then you will get the same number itself. Okay, by which number you will multiply any number, then the product is also should be, we will get a same number. How it is possible and when it is possible? If you take that 1, then only it is possible. So which means a into 1 is equals to 1 into a is equals to a. So only in this case only it is possible. Okay, if you take 1 into something, 1 into any natural number, then only it is satisfying. Okay, or 1 into any whole number, then only it is satisfying, or 1 into any other number, okay, rational number or real number, okay, then only you will get that same number itself as a resultant. Okay, so that's why take that natural numbers. Natural number 10 is multiplied with 1 or 1 into 10. In those two cases also you will get the same number itself as a resultant, no? Okay, 10, 10, 10. Okay, so come to that whole numbers. Take that 0, 0 into 1, 1 into 0. Again you will get it as a 0 as a resultant. Okay, and come to that integers. Minus 2 into 1, 1 into minus 2. You will get a resultant as minus 2. Okay, so when you observe these all cases, here which number is in as acted as a identity, which number that is 1. So here which element we will call it as a multiplicative identity means 1. So 1 is called multiplicative identity in all types of numbers, and 0 is called additive identity in all types of numbers. Okay, I will ask you one question. Which element is called additive identity in real numbers? So which identity is called additive identity? Which identity element? That is 0. Either that is in real numbers or rational numbers or integers or whole numbers or natural numbers. Okay, in all cases additive identity is 0. What about that multiplicative identity? I told you that in natural numbers additive identity does not exist, no? So that's why here in natural numbers 0 will not be there. In whole numbers 0, integers 0, rational numbers 0, real numbers 0. Okay, that is that additive identity element. In that natural numbers, which element is called additive identity element? Does not exist. Additive identity element in natural numbers. In natural numbers, what is that? Does not exist. Does not exist. Why? Because in natural numbers 0 is not there, that is the reason. Okay, so what about that multiplicative identity? Multiplicative identity satisfies in that all cases or not? Yes, in that natural numbers 1 is there, so here satisfies. Whole numbers there, so satisfies. Integers, rational numbers, real numbers. So in all cases we have that 1, right? Okay, that's why in all cases also that is possible. So what is the multiplicative identity in that rational numbers? 1. What is the multiplicative identity in natural numbers? 1. What is the additive identity in natural numbers? Does not exist. What is the additive identity element in real numbers? 0. Okay, what is the additive identity element in that? Integers, that is also 0. Okay, so this is about that identity property. Okay, so next we will discuss about that inverse property. So next one, inverse property. Okay, so here additive inverse, and here multiplicative inverse. Okay, here we can observe that these two, one is additive inverse, another one is multiplicative inverse. So what is the definition? Let A be any integer or any number. Why? Because we are talking about all the numbers together, no? So that's why let A be any number, then A plus of minus A is equals to minus a plus of a is equals to 0. If you add a number to its additive inverse means we have to change that sign of the number. If you add those two numbers, the resultant should be 0. Okay, then only that property holds. So additive inverse of additive inverse of 2. Additive inverse of 2 is minus 2. Additive inverse of 10 is minus 10. Additive inverse of 100, that is minus 100. Additive inverse of minus 100, that is 100. Okay, just we have to change that symbol. Positive symbol is there means a negative symbol. Negative symbol is there means a positive symbol. Why? Because this one happened, ma'am, means here 100, a is equals to 100 plus of minus 100. Okay, so 100 plus into minus is equals to minus 100. So you will get it resultant as 0. Get that resultant as 0. Okay, so here where it will be satisfies. So here I am going to take that 2 and minus 2 as example. 2 and minus 2. Is 2 there in that natural numbers? Yes. Minus 2 there in that natural numbers? Not there. Okay, 2 is there. Is there additive inverse of 2? Additive inverse of not only 2, additive inverse of any natural number. Is it exist in that type of natural number? Not exist. Why? Because in natural numbers we can observe that only positive values. Only positive values. That's why here in natural number it should not be exist. Okay, and in whole numbers also does not exist. Why? Because in whole numbers also we can't say that any negative integers, no. That's why they are also not possible. Where it is possible? In that integers. Why? Because integers only we are having that negative values. Okay, in that natural numbers and whole numbers we are not having any negative values, no. That's why here these two not satisfying. Where it will be satisfied means integers. Integers satisfied means integers there in that rational numbers also, no. So rational numbers also satisfies. Okay, so integers rational number satisfies. In those two cases also there in that real numbers, no. So here also satisfies. Okay, so additive inverse that exists in which type of numbers means integers, rational numbers, real numbers. In those three types of numbers only here additive inverse will be existed. Okay, next come to that multiplicative inverse. Before going to discuss about that, what is that multiplicative inverse of a particular number? Okay, so here let a be any number, then a into multiplicative inverse means the reciprocal of a number is equals to 1 by a into a is equals to 1. Okay, that is that condition, that is a into 1 by a is equals to 1 by a into a is equals to 1. Multiplicative identity is nothing but a reciprocal of a number. Multiplicative inverse means reciprocal of a number. Reciprocal of a given number is called multiplicative inverse of a given number. Multiplicative inverse of a given number. Actually this is that definition for that multiplicative inverse of a given number. Okay, okay, so here reciprocal of a given number, reciprocal of a given number is called multiplicative inverse of a given number. So multiplicative inverse of I'll give you some numbers here. Multiplicative inverse of 2. What is the multiplicative inverse of 2? That is 1 by 2. Multiplicative inverse of 3. That is 1 by 3. Multiplicative inverse of 4. That is 1 by 4. Okay. Multiplicative inverse of 1 by 2. That is 2. Just reciprocal. Okay. So just converse. And here 1 by 3. That is 3. Okay. So what about that multiplicative inverse? Multiplicative inverse is nothing but the reciprocal of a given number. Reciprocal means its inverse. A is there means its reciprocal is 1 by A. 1 by A, its reciprocal is A. Okay, so that is about that multiplicative inverse. Now we have to observe that here 1 by 2 is there. 2 is there, 2 is related to natural number. Okay, satisfying. What about that 1 by 2? Is 1 by 2 we can observe in that natural numbers? We can't observe that. Why? Because natural numbers means only positive values are there. So that's why here does not exist. Okay, here 1 by 2 fraction form not there, no. Whole numbers, is it possible to see the fractional form? Here also does not exist. Come to that integers. Integers, is it satisfies? In integers also we can't see that fraction form. Where we can observe that fraction form? Here in rational numbers and real numbers, but the condition is q should not be equals to 0. In q by form, p by q form, q should not be equals to 0. Okay, in those two conditions only we can say that rational numbers and real numbers are under multiplicative inverse, that one satisfying. Okay, so this is about that additive inverse and multiplicative inverse. So this is about that inverse property. Okay, after that the last final property, that is the distributive property. Okay, next one, distributive property. So what is the condition for the distributive property means, here let A, B, C are any three numbers. A, B, C are any three numbers. Any three numbers, then A into B plus C is equals to A into B plus A into C. A into B plus A into C. This is the condition for that distributive property. Okay, so under addition only it will be satisfied, under subtraction it will not be satisfied. Okay, just under subtraction means here minus symbol will come, it will not be satisfied. So distributive property mostly we will discuss under only addition. Okay, so distributive over addition are not, just we have to observe that. Under that natural numbers, whole numbers, integers, rational numbers and real numbers. So in all cases it will be satisfied or not, just to say that. So here A is equals to 2 and B is equals to you can take for that natural numbers, no? So take that positive values, 3 plus 4, which is equals to 2 into 3 plus 2 into 4. Okay, so how you will get here? 2 into 3 plus 4 is equals to 7, and here 2 into 3 is equals to 6, and here 2 into 4 is equals to 8. So 2 7s 14, 6 plus 8 is equals to 14. So it is satisfying or not? Okay, here I will tell you one thing. What about the distributive property means, for example, if you will go to that one of that shop, okay, for stationery shop, you want to purchase that books and pens. You want to purchase that books and pens. You want to purchase 2 books, 3 pens. 2 books and 3 pens. Okay, you purchase those two. Now here the cost of each notebook is 10 rupees. Cost price of each notebook. Cost price of each book is 10 rupees. Okay, and the cost price of each pen is 5 rupees. Cost of each pen is 5 rupees. Now here 2 books. How much amount you have to pay for that shopkeeper for only books? So how you will calculate? 2 into, you taken here 2 books and here each book is equals to 10. So here you have to pay for that 20 rupees for that only books. Okay, how much amount you will pay for that 3 pens? Okay, then here 3 into each pen is equals to 5, then 3 5 is 15. Is it clear? Okay, just observe that carefully. So if you don't know that totally how much you have to pay, you don't know that, just you taking the 2 books and 3 pens. So how you will pay that amount to that shopkeeper? Okay, so you taking 2 books, no? Each book cost is 10 rupees. So 2 into 10 is equals to 20 rupees. First you given 20 rupees to your shopkeeper. To that shopkeeper you given that 20 rupees for that notebooks. Next come to that pens. So what is the cost price of pen here? One pen cost is equals to 5 rupees. So what is the cost of 3 pens means 3 5 is 15. So next you paid that 15 rupees. Okay, that is one of the method. But here 20 rupees you given to shopkeeper, 15 rupees also you given to shopkeeper only. Why can't you give that those two money as together? Why can't you give that? Okay, so how much at last you had? 20 rupees you given, 15 rupees you given. So from yours, how much amount you have to pay to that shopkeeper? 20 plus 15 is equals to 35 rupees you given individually. Okay, now you have a thought, what is that? Why I am paying like that? Why can't I pay that amount all together? Okay, so here what is the cost price of 2 notebooks? That is 20. Okay, what is the cost price of 3 pens? That is 15. So 20 plus 15. At the same time you can give that so here you can pay that 20 rupees and 15 rupees also, no? So altogether you can pay that 35 rupees at a time. So here just observe that which concept I told you, that the same concept we can apply here. That is, this is A into B. A into B means the first amount how much you paid to that shopkeeper for that books. Next A into C. This is the amount you can pay for that shopkeeper for that pens. Okay, and this is that if you add the total amount of how many books and how many pens, okay, and what is the total cost, okay, that is A into B plus C. Okay, that's why here that is a distributive property. Okay, so A into B plus C is equals to A into B plus A into C. So is it satisfies under that natural numbers? Yes, under that natural numbers it will be satisfied. Okay, next whole numbers, if you take that whole numbers then also it satisfies. Next integers also satisfies. Next rational numbers also satisfies, as well as real numbers also satisfies. So distributive property satisfies under that all types of numbers. So easily we can say that natural numbers are distributive over addition, whole numbers are distributive over addition. Okay, integers are distributive over addition. Here always we are taking that addition, sum of the total amount only, no? So that's why here next rational numbers are distributive over addition, and finally real numbers also distributive over addition. Okay, so this is about that properties of numbers, okay, related to all types of numbers. So up to now how many types of properties we discussed here, and what are those? Here first one is closure property, next commutative property, associative property, additive identity, multiplicative identity, which is identity property. Next inverse properties we discussed, and at last we discussed that distributive property. So totally 6 properties are there related to that all types of numbers, and each and every property we discussed under addition, subtraction, multiplication and division. 4 fundamental operations also we discussed. So this is very very important, that properties of numbers and total number system concept also very very important. At starting of that video also I told you that this is very very important for that competitive examinations, as well as it will, one of that useful thing is there. What is that? It will it increases speed of your calculations. Okay, if you know that number system very well, it increases your speed of calculation. Okay, so up to here number system topic completed. Okay, we will again meet with another concept. Okay.